Hi guys, it's Mrs. Millison. All right, let's do the check your understanding on page 119. The distribution of heights of young women age 18 to 24 is approximately normal with a mean of 64.5 inches and a standard deviation of 2.5 inches. So I'm just going to make my notation for normal distribution, 64.5 inches and standard deviation of 2.5, and I always put the units on the outside. Okay, first question says sketch, whoops, can you see that? First question says, sketch the normal curve that approximates the distribution of young women's height. Label the mean and the points that are 1, 2, and 3 standard deviations from the mean. Okay, so I'm going to draw my normal curve. Make it nice and big so I can fit everything. Okay, here's my mean, which is 64.5. Then I'm going to go 1, 2, and 3 standard deviations above. So I'm just going to add 2.5 inches every single time. So 64.5 and 2.5 is 67. Add 2 more, that's 16, or 2.5 more, 69.5, and 2.5 more is 72. Then I'm going to go, the opposite way. 1, 2, and 3 standard deviations below the mean. So I'm going to take 64.5 and I'm going to subtract 2.5. So I get 62, subtract 2.5, I get 59.5, and subtract 2.5, and I get 57. Okay, so that is my, all my standard deviations in my normal curve for the heights of young women aged 18 to 24. Okay. Second question says, about what percent of young women have heights less than 69.5 inches? Okay, so here's 69.5 inches. And it says show your work. Okay, so I need to find that area. All right, we know by the empirical rule that 68% of the data in a normal curve is between 1 standard deviation above and below the mean. 95% of the data is in a normal curve is between 2 standard deviations, right, above and below the mean, and then 3 standard deviations gives us 99.7%, almost the whole thing. Okay, so we just got a little bit on the tail here, like 0.3%. Okay, so how you figure this out is up to you. A lot of people do it differently. Okay, I think what I'm going to do is, so I have my 69.5 inches. So I know from this point on, this is 50%, right? Because my mean splits my curve in half, okay? So I know this chunk right here is half of 68. So I know that's 34%. So then I just need to find this chunk. So if I can find the difference between 68 and 95, okay? What's that, 27? So these two chunks make up 27%, and if I divide that by 2, I know each of these is 13.5%. So if I add all those up, I get, what is that, 97.5%, okay? So that's my work. Now, you can do it a different way. Let's try to do it a different way. So I know, let me go this way again. Let's think of a different way to do it. I know the whole curve is 100%. So if I can just subtract this part, right, from 100%, then I can figure out the part that's highlighted. Okay, I can find the part from 69.5 to the left. So how can I figure out this part? Well, same thing. Let's do the difference. Let's do the difference between 95% and 100%, because that'll give us these areas, and then we'll just cut it in half and we'll get that area. So the difference between 100 and 95% is 5%. Divide that by 2, that's 2.5%. So if I take 100 minus 2.5, I'm also going to get my 97.5%. Okay, so it doesn't really matter how you do it. Just use your empirical rule to figure out your chunks and to figure out the area that you're looking for. Okay, either one is fine, just show your work. All right, last one, number 3. Is a young woman with a height of 62 inches unusually short? Okay, here's 62 inches, right? So 62 inches is just one standard deviation below the mean, okay? One standard deviation below the mean isn't all that unusual, okay? Because remember, 65%, 68% of the data falls within one standard deviation. So being anywhere in this part of the curve is not that unusual. When you get beyond 3 standard deviations, that's where it becomes unusual. So we're going to say no. A young woman with a height of 62 inches is not unusually short. Since 62 inches is just one standard deviation below the mean. Okay. Hope this was helpful, and I'll see you next time.